Alright, so this is part 2 of how to find derivatives of different types of functions. I'm going to look at a logarithmic function right now. And I've got the formula for how to find a derivative of a logarithmic function of this form. So b is the base, u is a function of x. And so let's make up an example. Maybe it's something like y equals log base 2 of 4x to the 5. Okay. And so we want to establish, again, as always, what is u? If I'm looking in this sort of a format, this value here is our u. So u is 4x to the 5. And what is b? b is the base. In this case, in this particular function, b is equal to 2. And so we're going to need u. We will need the b, which we got. E is Euler's number e, which always stays as e. And we'll need du dx. So let's find du dx. So over here, u is equal to 4x to the 5. So du dx is equal to 20x to the 4. All right. Now we've got everything we need to plug into this derivative. So y prime will be equal to 1 over u. So 1 over 4x to the 5 times log base b, in this case is a 2, of e, and multiplied by du dx, which is 20x to the 4. I'll put that in brackets. Okay. From what you studied about logarithms, this is an expression that represents the exponent that 2 is raised to equal e. This all stays together. This value, however, can come over and combine with this one, just to tidy this all up. So this becomes 20x to the 4 over 4x to the 5 log base 2 of e. And we can simplify this some more too, right? So the final answer is 5 over x log base 2 of e. And that 5 over x comes from, this cancels to a 5, this cancels to a 1. These all cancel out, leaving 1 down here. And that's a logarithmic one. Now sometimes you have to deal with a natural logarithmic function, and so here's the formula for a natural logarithmic function of the form ln u. That's where the logarithm has a base e. Just for some background in this case, ln of u is the same thing as saying log base e of u. It's just not written this way. All right, let's make up a natural logarithmic question. So how about y equals 2.4 ln x cubed. And let's look for the derivative of this function. Remember, this is just a coefficient that we are going to carry down and multiply by our derivative. So we're really just focused on this part right here. What is u? U is x cubed. We also need du dx. So du dx is 3x squared. All right, ready for the derivative. Y prime is equal to 1 over u multiplied by du dx. Oh, and I forgot something. Coffee, that's probably what I forgot. No, I forgot the 2.4. There we are. Okay, so y prime is equal to 2.4 times 3x squared over x cubed. That will be, all right, so we can cancel that, leaving one of these down here. So it's 2.4 times 3 x. (7.2 over x, I believe. Yes. Okay. So there's a natural logarithmic type. All right. Next we will look at the exponential functions. Okay, so for the exponential functions, I'm just going to make one up. Y equals 5 to the 2x to the 4. Okay, what makes this different from other types of functions is now you'll see that the x is in the exponent. All right, x is in the exponent makes this an exponential function. Before we've seen the, sorry, did I say y? I mean x. X is in the exponent. That makes an exponential function, rather than x being in the base raised to a power. Okay, so you can recognize these in this because of this particular feature. All right, so recognizing it's an exponential function, it's of the form b to the u. We need to establish what's b. B is the base, and u is the exponent. And we will also need a du dx, so that is 8x cubed. Okay, it's an exponential function, so its derivative is found by plugging everything into this form right here. So y prime is going to be 5, 2x to the 4. That's this first part, b to the u. Now ln b, ln 5, and multiplied by du dx, 8x cubed. There's not a whole lot of simplifying we can do. One of the things I would probably recommend is, because ln 5 represents an exponent, we don't want anything to get mixed up with that particular part of this whole expression. I might just maybe move this as a coefficient in front, so something like this would be a little bit neater. That way we don't accidentally get it tagged on to the end there. Okay, and so there's an exponential function type. Okay, one of the last types that we looked at was another type of exponential function, which is a special case where the base is e. But it still has the same sort of quality. We don't have the ln b in here. One of the reasons we don't have the ln b, if the base is equal to e, then ln e in the last formula, well, this means this also means log base e of e, and this is representing the exponent, what is e raised to equal e? Well, that must be 1. And so that's why it doesn't even exist in here, because there's actually a 1 in there. Just a little side note. Okay, let's make one up. What about y equals e to the 6x squared? Right, so u is equal to 6x squared. Du dx is equal to 12x, and therefore y prime is equal to e to the 6x squared, e to the u, multiplied by 12x. Okay, often we just put that back in front as well, make it for the coefficient. 12x e to the 6x squared. Finished. Okay. Lastly, we're going to wrap this all together, and we're going to do a function that involves a product of two different functions. We'll find its derivative. Okay, so we are going to do something like y equals 2 to the 4x sine 6x. Okay. Now, we want to recognize that we have two different functions of x. we have an exponential function there and a sine function here. X appears in two different places. They're being multiplied together. So we need the product rule. So the product, the derivative of a product is u times dv dx plus v times du dx. Alright, so we're going to call one of these functions u and the other one v. Let's go with that being a u and that being a v. So if u is equal to 2 to the 4x, du dx is equal to, back to that exponential one, so 2 to the 4x ln 2 times the derivative of u, which is 4. Tidying that up, we just have 2 to the 4x, 4 ln 2. And our v is equal to sine 6x dv dx is equal to cos 6x times 6, or 6 cos 6x. Alright, we are now ready to find the derivative using the product rule. So y prime is equal to u 2 to the 4x multiplied by dv dx, 6 cos 6x, plus b sine 6x multiplied by the derivative of u, 2 to the 4x, 4 ln 2. Okay. Now, there's probably some tidying up I should be doing in here. Actually, there's not a whole lot we can do. This is raised to the power, so we can't multiply the base by 6. Same with here. We could common factor, I suppose, but that's not really necessary. Let's just common factor, just go ahead. This only common factor is 2 to the 4x. Right? Yes, so 2 to the 4x, leaving 6 cos 6x plus sine 6x, 4 ln 2. Not really the nicest one, but anyway, that's how that one all works. And we are finished with part 2 of this video series. Thanks for watching.